Assalamu alaikum viewers. Today we are going to discuss an 8th grade challenging math problem. Problem starts with a statement which says that -1 is equal to -1 and concludes at a statement that says -1 is equal to 1, and we are asked to figure out the mistake. Let's see the problem. -1 is equal to -1. Every real number is equal to itself. Then we write -1 is equal to -1 over 1. Then -1 is equal to 1 over -1. In this step we shifted this negative sign from numerator to denominator. I think it's very clear, we can write it. Then by taking square root on both sides, we have square root of -1 is equal to square root of 1 over -1. So square root of 1 is equal to 1 and square root of -1 is equal to square root of -1. Then by multiplying both sides by -1, we have this expression, and if we divide square root of -1 with square root of -1, we have this last expression which says square root of -1 is equal to 1. Since taking square and square root are anti-processes of each other, they can cancel each other, and hence we will reach at this result which says -1 is equal to 1. So now look at this solution and try to find out the mistake. Before we go to the explanation, I would like to request you to please like and share my videos, subscribe my channel, and don't forget to press bell icon so that you can get my videos right on time. Once again, have a look at this problem. Have you found the mistake? Now I explain how we can figure out the wrong step. Consider two numbers a and b such that square of a is equal to b. Then it can be verified that square of -a is also equal to b. This implies that square root of b is equal to a, as well as square root of b is equal to -a. Or we can write that square root of b is equal to plus a as well as minus a. Here I introduce you with a term principal square root. The positive value of square root is called principal square root. I think the reason that made it difficult to figure out the wrong step is our experience. For example, look at this question. Simplify square root of 16 plus square root of 25. What we do? We write square root of 16 equal to 4 and square root of 25 equal to 5, and then add 4 and 5 to get 9. We never think about the possibility that square root of 16 can be -4 or square root of 25 can be -5. Why we never think about negative square roots? The reason is that everything remains pretty consistent with principal square root as long as we are dealing with square root of only positive real numbers. That is, when in a problem there are only square root of positive numbers, then there is no problem to write positive square roots, and there is no need to consider negative square roots. But this idea of principal square root no longer remains consistent when we come across a problem involving square root of negative real numbers. In such a case, we have to write both positive and negative square roots. This last paragraph is the key to solve our today's problem. I can summarize the whole discussion with this, that in such a case, when we are dealing with square root of negative number, it is better to write both positive and negative square root of the number. Now in this problem, the real point where we had made a mistake is this part. We should have written plus minus sign before this radical sign, and if we go on writing plus minus sign, we have this result: plus minus square root of negative 1 times plus minus square root of negative 1 is equal to plus minus 1 divided by plus minus square root of negative 1 times plus minus square root of negative 1. And using the fact that plus minus into plus minus is equal to plus minus, because plus plus is equal to plus and minus into minus is equal to plus, and plus into minus is equal to minus, and minus into plus is equal to minus, and by combining all these facts we have plus minus into plus minus is equal to plus minus. Hence we get this result, which finally comes this: plus minus 1 is equal to plus minus 1, which is very consistent, and there is no mistake in this calculation. Another way to explain this problem is with the use of the concept of complex numbers or imaginary number. If we replace square root of negative 1 by iota or I, the imaginary unit, we have iota is equal to 1 over iota. This implies that iota square is equal to 1. Oh, it's once again wrong result, because iota square is not equal to plus 1. Iota square is equal to negative 1. So where we have made a mistake now? Usually students don't consider this fact that iota is only principal square root of negative 1. What does it mean? It means that square root of negative 1 is not only equal to plus iota, but it's also equal to negative iota. And if we consider this fact, we can write this last line in this way. We will write plus minus iota instead of iota, and hence proceeding and calculating, we can reach at final result, which is equal to plus minus 1 is equal to plus minus 1, which is very consistent and a correct result of the problem.